All right, guys. Hey, 9.1 midpoint and distance formula. Hey, we've seen this before. We talk about this every year, which means it's a pretty big important deal to be able to find the midpoint between 2 points and the distance between 2 points, right, on a coordinate plane. So that's what we're going to do today. We're going to kind of review this idea, make sure you guys have these formulas down, and then apply them. Okay, so the midpoint formula, if you remember from previous maths, it's basically just taking the x values of the 2 points. So if you know 2 points, like let's just say, for instance, that we know that the 2 points are, we can totally make this up. So let's just say that the 2 points are 1, 4, and then let's just do 10, -1. Okay, so I totally just made that up. To find the midpoint between those, what you're going to do is you're going to just add, apologize for that, we're going to add the two x values together. So if I do that, that's the 1 and the 10. 1 plus 10 divided by 2 will be the x coordinate, and then the y value is added divided by 2. So 4 plus -1. 4 plus -1 would just be 4 minus 1 divided by 2. So the coordinate of the midpoint between those 2 points would just be 11 over 2, 3 over 2. And you might want to turn that into an improper fraction so you know where you're at. So that would be 5.5 and 1.5, right? So that's how you find the midpoint between two coordinates. So it says find the coordinates of the midpoint of AB if A is here and B is here. Okay, so again, same strategy. I'm going to take my x's, 5 plus -4, which is just 5 minus 4 over 2. And then the y's, so 12 plus 8 over 2. And so that becomes 1/2. And 20 divided by 2 is 10. Okay, so there's your coordinate of the midpoint. I want you to pause the video now and do 1b on your own. All right, let's look at 1b really quick. So this is going to be 18 over 2 and 18 over 2, I believe. So it's the same exact thing. 18 divided by 2 is 9. So this is 9, 9 as our midpoint. All right, so that's all we need to know for the midpoint. So we're going to have some practice, but that's it. And then the distance formula. What I want to remind you of, you guys, is that the distance formula is all it is the Pythagorean theorem. That's all it is. Okay. The Pythagorean theorem just says that a squared plus b squared equals c squared. We can turn any two points on a coordinate plane into a right triangle, right? So if I have the 2 points that are pictured here, it doesn't matter which direction I even go. I can go in the y direction first or the x direction first. It doesn't matter. But if we looked at this, if we knew this distance, the x, these are the x values, the difference in the x values, right? So where I am on the x here and where I am on the x right here will be the distance here that's in red, right? And then let me change colors here to green, I guess, or no, we'll go to black. The difference in the y would just be this distance from that red line to here. So you'll notice what I've just done is I've just created a right triangle, right? Where this distance here is just the change in y. So you could just call it, y2 minus y1. It's the change in the y values of the coordinates. And then this distance right here is x2 minus x1. Okay, so we know that the distance, the hypotenuse distance, is just going to be that thing squared, right? And then we have this piece squared. Those things added together will equal this piece squared, right? Which we can call c, or d for distance, or whatever you want to call it. So what you'll end up with is, the distance squared is equal to, it doesn't matter which order you do this in. I guess I'll do it the same order that they taught it in. So it'll be x2 minus x1 squared plus y2 minus y1 squared. So if I want to know what the actual distance is, I can take the square root of both sides, And there you have it. That is the distance formula right there. That's where it comes from. Right? So here's the distance formula. It's the change in x squared plus the change in y squared. Take the square root, and that'll give you the distance. So example 2 says Sharon hits this golf ball. Okay, we're going to make the hole at 0, 0. She hits this golf ball 12 feet above the hole, 3 feet to the left. So if we go left 3, up 12, we're here. This point here is negative 312. Okay, so that's where she hit the ball. Her first putt traveled to 2 feet above the cup and 1 foot to the right. So 2 feet up, 1 to the right would be here, and that coordinate is 1, 2. Careful, always do your x coordinate first, right? How far did the ball travel on her first putt? So they want us to figure out the distance between these 2 points. So again, we can apply the Pythagorean theorem, right? If you took so another way to think about this, you guys, if you don't want to like memorize this thing, is you could just always draw it out and look at your triangle. That's another option. We know that this distance from here to here is a distance of 4, right? And that's, notice that's just 1 minus negative 3, that's going to be 4, right? So it's a change in the x's. Then the change in the y's from 2 to 12, this distance is 10. So another way to think about this is just, we have 10 squared plus 4 squared equals the distance squared. Okay, so that's 116, right? 116 is equal to the distance squared. So the distance is equal to the square root of 116. Square root of 116 is, that's not a nice number. So let me just see what it comes out to here. If you put this in your calculator, you would either get, if your calculator does radicals, you would get 2 root 29 because a 4 can come out. Square root of 4 is 2, and then you're left with 29. Or if you're in decimal mode, you'd get 10.77, which is probably a little bit of a nicer thing for this particular problem, feet. It's easier to see and imagine 10.7 feet versus 2 root 29 feet, right? But anyway, that's number 2. Example 3 says the coordinates for these points are this guy and this guy, respectively. Find the distance between the midpoint, between the midpoint of A and B and point B. So here's point B. So they want us to do 2 things here. They first want us to find the midpoint. Okay, so let's find the midpoint, and then we'll use that and point B to find the distance, right? So the midpoint, so we're going to add the x's together. I get 6 over 2. And then add the y's together. Negative 5 minus 7 is negative 12 over 2. So the midpoint's going to be at 3, negative 6. Okay? So now I'm going to use that and point B. So you got to read your question carefully. That and point B, and I'm going to use my distance formula now. And I guess I'll just use the distance formula here instead of drawing it out. So distance is equal to the square root of the change in x. So that would be 10 minus 3 squared plus the change in y. Negative 7 minus negative 6 is negative 7 plus 6, which is negative 1. Okay, so I did that math in my head there, but you get the point. So the distance then here is going to be equal to the square root of 10 minus 3 is 7. 7 squared is 49. Negative 1 squared is 1. So we have the distance is equal to the square root of 50. And that is one of my answers, but if it wasn't one of my answers, notice that can be rewritten as the square root of 25 square root of 2, which is 5 root 2, which means the exact same thing. But since this was one of my answers, I'm going to stop there. All right, guys, that's it. So we'll do the homework together in class. Catch you guys.